Okay, in this video, we're just gonna go over some of the questions that could be on the test on Friday. So today we'll do chapter 1. I'm just looking on page 95 of the book. There's a bunch, well, there's a couple of pages in here. So we'll go over some of these questions. It's just like the review section from the book, and then we'll do chapter 2 video tomorrow. So this is gonna be. And so there's a bunch of questions, somewhere on page like 91 to 94. And then there's like a different chapter test on page 95 and 96. So let's see. Let's just go over the 95, 96 stuff. All right, so it's in the book, this is called like the chapter 1 test. Okay. So let's start with, let's do the first question. We didn't go over all this material. I skipped a couple of the things. So basically for the test, the questions will be one of the type of, it'll only be questions that we're going to do today and tomorrow. Maybe with different numbers, maybe it'd be the same question in some of them. But if it's not going to be on this review, then it won't be on the test tomorrow or the test on Friday. But just because it's on here also doesn't mean it's going to be on the test. Okay, so this is question number 1 is we want to determine whether this point is a solution to the given equation. So determine if the point 1/2 9/10 is a solution to what? 5y minus 4 is equal to x. Okay, so we're given this point. That means we're given an x value and a y value. So if we have this point 1/2 9/10, this is just telling us it's giving us an x and a y value. It's giving us an x value of 1/2 and it's giving us a y value of 9/10. And now we want to know if we plug those values into the equation, do we get a true statement? So what happens when we plug these things into 5y minus 4 is equal to x? What we want to do is we want to take these guys and plug them in here. So what happens? So what's y? Y is 9/10. So we have 5 times 9/10 minus 4 is equal to, and then x is 1/2. So let's simplify the left-hand side and see if we get what's equal on the right-hand side. So over here we have 5 times 9/10, but there's a 5 on the top and a 10 on the bottom, so we can cancel. So we're just going to get 9/2. 9/2 minus 4 is equal to 1/2. And on the left-hand side, we need to get a common denominator. So 9/2 minus 8/2. But if we subtract those things on the left, we do get 1/2 is equal to 1/2. So that's good. So from this, we know that 1/2 9/10 is a solution. Okay. How about number 2 is also a good question. Let's do that one. What we want to do is find the intercepts. When it says that, we mean the x and y intercepts, and then also graph a line. So so find the intercepts of 5x minus 2y is equal to minus 10, and then graph. So we need to find the x and the y intercepts, and then we need a graph. So the first thing to do is to find the x and the y intercepts. So let's start with the x intercept. So if you remember with the x-intercept, this means we need to set y equal to 0 and solve for x. Set y equal to 0 and solve for x. Okay, so if we do that, we're going to get 5x minus 2 times 0 is equal to minus 10. So if we minus 2 times 0 is 0, so we just get rid of that. So 5x is equal to minus 10. And then divide by the 5, we get x is equal to minus 2. So this tells us that our x-intercept is going to be the point minus 2, comma 0. So remember, the intercepts are a point. We're plugging in y to be 0, and then we're solving for an x value. So we plug in y to be 0, and we solve, we get x is equal to minus 2. Okay, now let's do the y-intercept. With the y-intercept, we're going to set x equal to 0 and solve for y. Okay, let's do that. So set x equal to 0. So we're going to get 5 times 0 minus 2y is equal to minus 10. So 5 times 0, that just goes away. So minus 2 times y is equal to minus 10. Divide by the minus 2, and we get y is equal to 5. So what we have is that our y-intercept is going to be the point. We plugged in 0 for x, and we get 5 for y. So there's our intercepts. And now what we need to do is graph. But remember, so when we're graphing a line, we only need 2 points. And by finding these intercepts, we get 2 points. So all we got to do to graph a line is put these 2 points on a graph and then just connect them with a line. So if here's our graph, we have a point on minus 2 comma 0. And we also have a point on 0 comma 5. And then we connect them. Okay, so that's all we need to do for this problem. Sorry, 1 second, let me be right back. Okay. So next question, what do we got? Let's do number 3 as well. So this is going to be a distance formula question. So we want to find the distance between these 2 given points. So find the distance between 5, 8 and minus 1, 5. All right, so first let's write down what the distance formula is. So the distance formula is going to be the square root. So we have 2 points. It's going to be x1 minus x2 squared plus y1 minus y2 squared. So if we're given 2 points, we just plug them into this equation. So we need to figure out, we have to label what's our x1, y1 and x2, y2. So this first point, let's just call x1, y1. And the second point, let's call x2, y2. So in our problem, the distance between the 2 points, 5, 8 and minus 1, 5. So this distance is going to equal, we have the square root. So we subtract the x value. So 5 minus negative 1. So x1 minus x2, squared, plus, and now let's subtract the y values, 8 minus 5 squared. So this is going to be the square root of, so 5 minus a minus 1 is 6, so that's 6 squared. And then that's 8 minus 5, which is 3, so 3 squared. So that's the square root of 36 plus 9. And that equals the square root of 45. And we can't simplify the square root of 45, so let's just leave the answer like that. Okay. The next problem, so it deals with the midpoint. So we want to find the midpoint between points minus 2, 6 and minus 4, 3. So our midpoint formula, so if we're given the 2 points, x1, y1, x2, y2, we add the x values. So x1 plus x2 divided by 2, and then we add the y values. Okay, now let's label our points. Well, we're given these 2 points. Let's call this one x1, call this one y1, call this one x2, this one y2. So in our problem, our midpoint is going to equal, we add the x values, -2 plus a -4. How do we copy the, let's see, -2, 6, -4, 3. Okay, we're good. Add the x values, divide by 2. Now add the y values, divide by 2. So -2 plus -4 is -6. So we have -6 over 2, and then 9 over 2. And this is going to equal -3, 9 over 2. All right. Let's do number 8. Let me turn this on. All right. Number 8. So we're given a function. So we're given this function, and we want to find just 2 things here. So the first thing we're going to find is just f of -1, which this one isn't nothing crazy. All we do is so you remember, whatever is inside this here, this box here, it's an x. That x we just place right here, and we replace right here. So now we're going to plug the -1 in right there. So we'll have 2 minus 1 squared minus -1 plus 5. So we're just plugging in -1 for x. So here we're going to get 2 times 1, which is 2. That becomes a +1 plus 5, which is equal to 8. Okay, that's good. So now for the next one, what we want to find is, this first bit. The second bit we want to find is f of a plus 2, right? Number 8. Yeah, a plus 2. Again, so we look at these green boxes up here. Whatever goes inside here, we're going to place here, and we're also going to place here. So now what we're going to replace there is an a plus 2. So we're going to have, first we write the 2, and then we have x squared. So a plus 2 squared minus x, so minus a plus 2, and then plus 5. So maybe remember this formula. If we have, so we don't use the same letters. So this is x and y. If we have this x plus y squared, this is equal to x squared 2xy plus y squared. So using that formula, we can simplify this first little piece to a plus 2 squared. This is going to equal 2, and then we'll have a squared. So a times 2 times, so 4a plus 4 minus a plus 2 plus 5. This over here, this is just a good formula to have memorized. Otherwise, let's put that off to the side. So what we're using that is, we're doing this formula over here to calculate a plus 2 squared. So using this formula above, this is how we got the a squared plus 4a plus 4. Otherwise, you have to use foiling. So you would have a plus 2, a plus 2. So the a goes to the a goes to the 2 goes to the a, and the 2 goes to the 2. So what you would get there is, a squared plus 2a plus 2a plus 4, and then you combine all the like terms and you get the same answer. So both of those are how I simplified that. Anyway, so now let's distribute the signs and stuff in front of the parentheses. So we have 2a squared plus 8a plus 8 minus a minus 2 plus 5. And if we combine the like terms, we get 2a squared plus 7a, and then 6 plus 5, so plus 11. Is that the right answer? 70, yeah, so no mistakes there. This is the right answer. Okay. Now let's do 12. So find the domain of f of x is equal to actually, I want to change this problem and make it a little bit different. Let's I'll just call this a problem similar to 12. So similar to 12. Find of 1 divided by x squared minus 7x plus 12. So let's find the domain of this. So remember, when we're finding domain, we always look for two things: fractions and then square roots. So do we have any of these things? Fractions, yes. Square roots, no. So we don't got to do anything for square roots, but with fractions, we do have those. And we look at our fraction. The one thing we can't have is that we can't have the bottom of a fraction being 0. The bottom of our fraction here is x squared minus 7x plus 12. So we can't have that being 0. So x squared minus 7x plus 12, this cannot be 0. So now we need to figure out what are those x values that make it 0. So what we do is we can factor this. We get x minus 3, x minus 4, can't be 0. And then set each of the pieces. So x minus 3, this can't be 0. X minus 4, this can't be 0. So we get x can't be 3, and x can't be 4. And then the next thing we do is we go into a number line. Here's 3, here's 4. If we can't be those, we put circles on. But now we stop right here. So with fractions, we're done. The only issue with fractions are when x is 3 and x is 4, so we get rid of those numbers. And we know that there's no square roots, so we can't have any problems with square roots, so there's no issue with that. So the only problems we have are 3 and 4, but we can shade in the middle. Nothing over there is bad. Everything over here is good, and everything over here is good. So then what we get for our domain is going to be minus infinity to 3, 3 to 4, and then 4 to infinity. And then just for naming reasons, this is going to be called graph notation. And then this is going to be, let's put a box here, interval notation. Okay, so there's our domain for this one. Let's do 14. We never really, let's not do 14. We'll do something similar to 14. So find the domain. Find the domain of, let's do g of x is equal to the square root 3 minus x. So again, with domains, are there fractions or are there square roots? So if we look at this problem, we see there's no fractions. So there's no reason, we're not setting anything equal to 0 here because there are no fractions, but there are square roots. So this answer is yes. So what we need to do with square roots is you have to take the inside and set it bigger than or equal to 0. So the inside is 3 minus x. This needs to be bigger than or equal to 0. So if we add the x over, we just get 3 is bigger than or equal to x. So on a number line, here's 3, and it's bigger than or equal to. So put a dot on here. And so x, it has to be less than or equal to 3, or 3 has to be bigger than or equal to x. So that means x can be over here. And so then our domain is equal to, parenthesis, minus infinity all the way up to 3. And 3 has a bracket now because it has a closed circle. All right. Let's do 17. So find the slope. Between 4 minus 10. And minus 812. So the slope formula, remember we use the letter m, so m usually means slope. So m is going to be, you subtract the y is y1 minus y2, and then you subtract the x's, x1 minus x2. So we have to label our points. Let's label this one x1, y1. Let's label this one x2, y2. So in our problem, our slope, subtract the y values, we're going to get minus 10 minus 12. So that's y1 minus y2. Now x1, which is 4. And then minus x2, which is minus 8. So then what we get is, so minus 10 minus 12 is minus 22. And then 4 minus a minus 8 is 12. So we could divide the top by 2, we get minus 11. Divide the bottom by 2, and we get 6. And so this is going to be our slope for this problem. All right, so the next problem. Now it's 220. So for this one, we're given an equation of a line. So we want to find the slope and the y-intercept. Find the slope and y-intercept of minus 3x plus 2y is equal to 5. So the easiest way to do this problem is we need to turn this line into slope-intercept form. So you remember slope-intercept form is y equals mx plus b. And then when we put our line into this form, here's the slope, the letter m, and then here's the y-intercept. So what we need to do is put this line into that form. So we take minus 3x plus 2y equals 5. And we want to make this y equals and put everything else on the other side. Basically, we want to solve for y. So let's add the 3x over. So if we add the 3x over, we're going to get 2y is equal to 3x plus 5. Okay? But we need to get the y alone. So let's divide everything by 2. So what we get on the left-hand side is y is equal to 3 halves x plus 5 over 2. But now it's in y equals mx plus b form. So here's mx plus b. So we know that our m, which is our slope, that's going to be 3 over 2. And our y-intercept, that's going to be 5 halves. But remember, it's a point. So it really means it's the point 0, comma 5 over 2. The y-intercept is 5 over 2, but we write it as a point. It's when x is 0, and then it's going to be, so if you plug in 0 here, you see the 3 halves goes away, and you're just left with 5 over 2. Sorry, let me blow my nose real quick. No, it's live. Doesn't matter. Okay, next problem. What do we have to do? Let's write an equation line. Let's do 22. It's kind of like the backwards version of this problem. So 22 says write an equation of the line. Write the with slope. Our slope is going to be, write an equation of the line with slope is minus 5 over 8. And y-intercept is going to be the point 0, comma minus 5. So all we need to do is just use the slope-intercept form. We're given the slope, we're given the intercept. So in this situation, it's just y is going to be minus 5 over 8, because that's the slope. So mx minus 5 over 8x, and then plus the y-intercept, which is minus 5. And then if we just simplify that a little bit to get rid of that plus minus sign, so we have minus 5 over 8, x minus 5. Okay, let's see. Oh, let's do 23 as well. So 23 says we want to write the equation of a line that passes through these 2 points. So write the equation of a line that passes through -5/4. Sorry, no, -5, 4, and 3, 2. Or 3 minus 2. Okay, so write the equation of a line that passes through -5, 4, and 3 minus 2. So what do we want? Well, the problem's asking for the equation of the line. So we want this. We want y is equal to mx plus b. So in order to complete the problem, we need to find what is m and what is b. So we know what m is. M is the slope. And we're given 2 points, we can find the slope. So to find the slope here, all we have to do is, do y1 minus y2 over x1 minus x2. Let's call this one x1, y1, and right there. So x1, y1, and here is x2, y2. So our slope then is going to be 4 minus, 4 minus minus 2 all over -5 minus 3. Let's see, 4 minus minus 2, and then -5 minus 3. So what we get here on the top is 6, and on the bottom is -8. So that's going to be -3/4. So with that, now we can plug that into our line. So we know that y is equal to -3/4 x plus b. So now what we need to do is find b. So what we could do is we could take any of the points that were given and plug it into this equation to solve for b. Let's just take 3 minus 2. So let's take the point 3 minus 2, and let's plug it into this equation. Oh, sorry, what's the equation I want to pass? Oh, okay. So now we need to take this point and plug it in there to solve for b. So y is -2. We're going to get -2 is equal to -3/4. X is 3 plus b. So we get -2 is equal to -9/4 plus b. So if we add the 9/4 over, we're going to get b is equal to 9/4 minus 2. And with the common denominator, we're going to get 9/4 minus 8/4. That's going to be 1/4. So we found b is 1/4. So now our line is going to be y is equal to -3/4 x plus 1/4. Okay. Perpendicular. Let's do 25. So 25 is we want to determine whether these given lines are perpendicular, parallel, or neither. So determine whether the lines are parallel, perpendicular, or neither. And the lines that it gave to us are 3x plus 3y. No, I missed. Sorry, 2x plus 3y. 2x plus 3y is equal to -12. And 2y minus 3x is equal to 8. Let's label these. Let's call this one line number 1, and this one's going to be line number 2. So what we need to do is, in order to find if they're parallel, perpendicular, or neither, we need to find the slopes of each of the lines. And, test. We had the definition for parallel slope, which means they're the same. Perpendicular is negative reciprocal, and neither would just be neither parallel or perpendicular. So the first thing let's do, let's put both these lines into y equals mx plus b form, since that's the easiest way to find the slope of the line. So for line number 1, 2x plus 3y equals -12. Let's subtract the 2x over. So we get 3y is equal to -2x minus 12, and then divide by the 3. So we're going to, let's do that. Divide by 3, divide by 3, divide by 3. So what we get is y is equal to -2/3 x minus 4. So here's line number 1. Now let's do the same thing with line number 2. With line number 2, we need to add the 3x over. Divide by the 2. We have y is equal to 3/2 x plus 8/2, which is 4. Okay, so now let's look at the slopes of each. So slope of 1. If we look at here, the slope is this thing attached to x, that's minus 2/3. The slope of 2, the thing, again, attached to the x, that's 3/2. So what we see here is that, so let's write this down to the side. So remember, parallel, this is gonna, so the definition of parallel, say if we have two slopes, this means m1 is equal to m2. So the slopes are equal to each other. And then perpendicular, this means that one of the slopes is equal to -1 divided by the other slope. So these are definitions of parallel and perpendicular. But notice that if we take one of these slopes, and let's do -1 divided by it, let's just take slope number 2. So if we did -1 divided by 3/2, this is equal to minus 2/3. So what we have is actually, these are perpendicular. So these two slopes, these are perpendicular. If you take this slope, turn it upside down, and put a minus sign in front, you get this slope. So there we have that these two slopes are perpendicular. All right. Let's do 26. So find the equation of the line containing the line containing the point -1, 3 and parallel. So parallel to x plus 2y is equal to -6. So the first thing we need to do is need to find the slope of this line, and we know we're parallel to that given line. So we need to find the slope of that line, because remember, parallel means the same slope. So if we take this line, so this line is going to be, so 2y, we can subtract the x over, -6. And then divide by the 2, we're going to get y is equal to -x/2 -3. And so we see that our slope of this line, m, is equal to -1/2. And so the parallel slope means with the same slope. So we want to keep that same slope. So the slope of our line is going to be, so we'll have y is equal to -1/2 x plus b. So we need to find what b is equal to now. Because remember, what we're looking for is this. We want to find y is equal to mx plus b. So we need to find our m and we need to find our b. Our m is the slope, and we're told that we're parallel to this line. So the same slope of that line. And we just found that the slope of that line was -1/2. So the slope of our line is -1/2. And now once we find that, we just need to find b. So what we could do is we could take our point, -1, 3, and then plug it in to the line over there. So y is 3. We're going to get 3 is equal to -1/2. X is -1 plus b. So we get 3 is equal to 1/2 plus b. So subtract the 1/2 over, we get b is equal to 3 minus 1/2. Common denominator, we'll have 6/2 minus 1/2, which is equal to 5/2. So b is going to be 5/2. So if we plug that in, we get y is equal to -1/2 x plus 5/2. All right. The next one, let's do 27. So 27 says basically the same question. So find the equation of the line that contains the point So it contains the point minus 1, 3, and is perpendicular to x plus 2y equals minus 6. So what we need to do is we want to find this. We want y equals mx plus b. So we need to find our slope and we need to find our y-intercept. We're going to start with our slope. So we know we're perpendicular to this line over here. Let's just figure out what that slope is of that line. So with this line over here, we're going to get 2y is equal to minus x minus 6. And if we divide by the 2 over, we get y is equal to minus 1/2 x minus 6. So the slope of this line is equal to minus 1/2. But we want the perpendicular slope. So we know the perpendicular slope is going to equal minus 1 divided by that slope. And so the minus 1 divided by minus 1/2, that's going to be positive 2. So this is the slope that we're looking for. So our line looks like this. Y is equal to 2x plus b. So now what we need to do is we take our point, minus 1, 3. In order to find b, we're going to plug that into this line over here. So we're going to get 3 is equal to 2 times minus 1 plus b. So 3 is equal to minus 2 plus b. And if we add the 2 over, we get 5 is equal to b. And so now we know our line is going to be y is equal to 2x plus 5. Okay. Let's do let's do 31. So we want to solve for y in the equation 3 halves y minus 4 is equal to 5/3 y plus 6. So we want to solve for y here. Just means we got to get y on one side of the equal sign and everything else on the other side. So let's first start by adding the 4 over, and then so we can add 4 on both sides. So let's add 4, and let's subtract 5/3 y to the other side. So then what we're going to have is we'll have 3 halves y minus 5/3 y, and that's going to equal 6 plus 4, which is 10. So we need to get a common denominator on the left-hand side. So we have, really how we can write this, this is going to be 3y divided by 2 minus 5y over 3 is equal to 10. So our common denominator is going to be 6. So what we need to do is put a 3 on the bottom of the left, and so a 9y over 6. And then we need to put a 2 in the bottom and the top over here, so 10 over 6, 10y over 6. Okay, so that's all we did here is just get a common denominator. This is a 9. So now we can subtract the tops. We have 9y over 6 minus 10y over 6. So 9y minus 10y is just minus y. So what we have is minus y divided by 6 is equal to 10. And then what we need to do is multiply the minus 6 to the other side. So we get y is equal to minus 60. Okay, 32. We have 2, 4x plus 1 is equal to 8 minus 3, x minus 5. And then we want to do is solve for x. So the first thing we need to do is we need to distribute everything in front of the parentheses. So we're going to have an 8x plus a 2 from distributing the first bit. Then we have 8, now minus 3x, and then plus 15 from distributing the minus 3 on the second half of the parentheses. So now let's get the 8, the x's on the same side. add the 3x, add the 3x. And let's also subtract the 2 over. So on the left-hand side, we just have 8x plus 3x, which is 11x. On the right-hand side, we have an 8. Let's just rewrite it. 8 plus 15 minus 2. So what we get is, let's simplify the right-hand side. 8 minus 2 is 6. 6 plus 15 is 21. Okay, and then divide by the 11, so we get x is equal to 21 divided by 11. All right, let's do 36. So we want to solve this inequality. 5 minus x is bigger than or equal to 4x plus 20. All right, so let's get the x's on the same side. All we do is just add the x over here, add the x over here. So then we get 5. It's bigger than or equal to 5x plus 20. And then we could subtract the 20. And then what we get is minus 15. It's bigger than or equal to 5x. And then we divide by a 5. And we're dividing by a positive number, so we're not going to change the sign. So what we get here is minus 3 is bigger than or equal to x. So here's one way to represent the answer. Another way on a number line. So here we have minus 3. It's a bigger than or equal to sign. So we got this. So this is saying minus 3 is bigger than or equal to x, or x is less than or equal to minus 3. So we shade to the left. So here's another way to represent the answer. And another way is going to be the interval notation. So minus infinity up to minus 3. Let's do one similar to 37. So similar to 37, let's do this one. Let's do minus 7. Less than or equal to 3 minus 2x, which is less than 11. So we have to get, in this one, we got to get x alone in the middle. So first, let's subtract the 3. Subtract the 3, subtract the 3. And adding and subtracting, we don't change the signs. That's only multiplication and division. So subtracting 3, that's okay. So we just have minus 10. The sign stays the same. And then in the middle, we have minus 2x. And on the right, we're going to have 11 minus 3, which is 8. So now we need to divide by a minus 2. And now because we're dividing by a minus, we do have to change the signs around. So minus 10 divided by minus 2, that's positive 5. This sign turns around. The minus 2's cancel. Then the sign turns around. And then we have minus 4. So here's one way to represent the answer on a number line. So we have minus 4. We have 5. The minus 4 has a greater than sign, so we have an open circle here, and the 5 has a less than or equal to sign. So we have this. So this is saying that x is less than or equal to 5. So for less than 5, we shade to the right. And at the same time, it's bigger than or equal to 4. So we shade to the right of 4. So to the left of 5 and the right of 4, which is this middle section. So here's one way to represent the answer. And then the last way will be from minus 4 up to positive 5 with a bracket on 5 and a parenthesis on minus 4. That's actually good. We're good with that. So all these problems, we'll stop here for the day. So you have time just to go over chapter 1 today, and you can do chapter 2 tomorrow. So as far as chapter 1 goes, the only problems that will be on the test are going to be something along these lines of these problems. And we'll do the same thing tomorrow with chapter 2. If you have any questions, feel free to email me. But yeah, so we'll continue tomorrow with chapter 2. Cool. Thank you.